The second objective in this topic is dividing a polynomial. Let's go ahead and review long division. Let's say we have 273 divided by 3. Three would not go into 2. So we expand. 3 goes into 27 9 times. So we put the 9 above the 7 because that's where we are in terms of dividing. We haven't brought 3 into it yet, but we had to go to the 27. So the 9 ends where the 27 ends. Then, as I like to say, we're going to multiply around the corner. 9 times 3 is 27. We write our answer underneath and we subtract the whole 27. From this 27, we're left with 0. But we're not done because we have this 3 that we bring down and right here. Now we do the same thing except with this number down here. We're done. We're still dealing with the 3 because we brought it down. That's why we're down here now. 3 goes into 3 how many times? 1 time. Multiply around the corner. 1 times 3 is 3. We subtract. Once again, we get 0. And since there's nothing else to bring down, what we have here is our remainder. In this case, we have no remainder. So 273 divided by 3 is 91. Let's do a problem with a remainder. 4 divided by 231. 4 does not go into 2. 4 goes into 2 0 times. It's like there's a 0 up here. Expand. 4 goes into 23 how many times? 4 goes into 23 5 times without going over. Price is Right rules. Multiply around the corner. 5 times 4 is 20. We subtract the whole thing. 23 minus 20 is 3. Bring down the 1. 4 goes into 31 how many times? 32 is too much, so 8 is too many. It must be 7. 7 times 4, multiplying around the corner, is 28. Subtract. We have a remainder. 31 minus 28 is 3. So there are a few ways that we know to deal with remainder when we're dividing. One of them is to just write R3, 57 remainder 3 as an answer. But once we start learning fractions and decimals, we no longer use 57 R3. Maybe we can do it as a decimal. What would we do for a decimal? We put in a 0.0 and we just keep going. Bring down the 0. 4 goes into 30 7 times again. Since we put a decimal point here, we have to put a decimal point in the answer in the same spot. 4 goes into 37 times, 28, subtract. We have another remainder, but since we're decimal, we keep going. Put in a 0, bring it down. 4 goes into 20 5 times evenly. And when we're finally done with no remainder, we have our answer. So we could also say 57.75. I've saved the one we're interested in for last. If we go back to where we had our 57 remainder 3, the third way we know to write remainders is to take the remainder of 3, make it a numerator for a fraction that has a denominator of 4, denominator of whatever's on the outside. So 57 3/4. When we divide polynomials using long division, this fraction remainder piece, that is the closest equivalent to how we deal with having a remainder. When that comes up, we'll deal with that. Your ears probably perked up and you said, dividing what now? What are we dividing? We are dividing polynomials. Like I want a nice easy one that's going to work out. Let me choose x squared minus 6x plus 8 divided by x minus 2. Now, when we do, for instance, 12 divided by 3 to get 4, or 12 divided by 4 to get 3. The reason these work as division problems is because the corresponding multiplication is that 3 times 4 equals 12. So we can take 12, the big number, the product, the answer, make that the number that we are starting with. And then if we divide by either of the factors, we get the other factor. Now, we know from our work with factoring that x minus 2 times x minus 4 would be x squared minus 6x plus 8. So this logic means that if we take the x squared minus 6x plus 8 and we divide by one of these factors, x minus 2, we would get the other one, x minus 4. So I'm expecting to get an answer of x minus 4 when we do the division. But how do we set it up? That's what we're going to focus on today. Just like a long division problem, 12 divided by 3 would be 12 divided by 3. The first thing in the division problem goes underneath. X squared minus 6x plus 8. On the outside, the thing we're dividing by, x minus 2. Here are the steps. We're going to look at just the first term, and we're going to ask ourselves, this times what gives us the first term here? Ignore the rest. We're just looking at the first term. This is the equivalent in the long division problem of asking how many times does the thing on the outside go into whatever. We're trying to get there with multiplication. So x times what is x squared? X times x is x squared. Now we're going to multiply around the corner, but multiplying around the corner in this context is going to be taking what we have, we just found this x, and multiplying it by the entire thing we're dividing by, multiplying it by the entire x minus 2. And what happens when we multiply x times x minus 2? We distribute. X squared minus 2x. Just like in the normal division problem, we are going to subtract. But when we subtract, keep in mind that's the entire thing. We're not just subtracting the x squared, we're also subtracting the negative 2x, which means that turns into minus a negative plus. So let's do this. X squared minus x squared cancels away. Negative 6x minus negative 2x is negative 6x plus 2x, negative 4x. Bring down the rest, plus 8. So very similar steps to the regular long division. What do we do next? Well, we brought the stuff down, so we're done with the lines up here. Now we're focusing here. We're going to do the same thing. Look just at this first term. Look just at this first term. This times what gives us this? X times what is negative 4x? X times negative 4 is negative 4x. Go around the corner. This negative 4 that we just found times the entire x minus 2. Negative 4 times the x minus 2 would be negative 4x. Negative 4 times negative 2 would be positive 8. We are subtracting the entire thing. Negative 4x minus negative 4x. Negative 4x plus 4x. That cancels away. 8 minus positive 8. 8 minus 8. That cancels away. No remainder. Our answer, just like we predicted, x minus 4. Let's do some more work. We got to learn this process. Let's take a look at 6x cubed minus 5x squared minus 3 that divided by 3x plus 2. So now a word of warning when we set these up. when we put the first thing under the division. 6x cubed minus 5x squared. Notice there is no x term. And because there's no x term, we need to put a plus 0x here before the minus 3. So there's no x term. We need to basically make a placeholder, because when we do all this subtraction, notice in the last problem, the x's kind of lined up with the x's. The way it works out is if we don't leave a placeholder for the x, then we don't have a place to put our x's and the whole thing falls apart. So if we're missing a specific term, whether it's the x squared or the x, we have to account for that by putting a placeholder in. And we're dividing by 3x plus 2. Let's do our steps. Look just at the first term. 3x times what is 6x cubed? Well, 3x times 2x squared is 6x cubed. And if we're right about that, that first thing will cancel out when we multiply around the corner. 2x squared times this entire 3x plus 2. 2x squared times 3x, that's positive 6x cubed. 2x squared times positive 2, that is positive 4x squared. We subtract the entire thing. 6x cubed minus 6x cubed, that goes away. Negative 5x squared minus positive 4x squared. Negative 5 minus 4 would be negative 9x squared. Bring down the rest. Plus 0x minus 3. Now we're done with this stuff up here. We're going to do it again, looking there. Ask yourself, positive 3x times what is negative 9x squared? Positive 3x times negative 3x would be negative 9x squared. Multiply around the corner. Negative 3x times the entire 3x plus 2. Negative 3x times positive 3x is negative 9x squared. Negative 3x times positive 2 is negative 6x. This is why we needed the placeholder column. We're going to subtract the whole thing. Negative 9x squared minus negative 9x squared is negative 9x squared plus 9x squared. That goes away. 0 minus negative 6x. That would be 0x plus 6x, or positive 6x. Bring down the minus 3. We continue. Now, make sure we have this written down. I'm going to do some fancy, quick work. Move this up and give myself a little more room. Unfortunately, that means I'm going to have to rewrite some stuff, so it'll be no time at all for you. And flourish. Magic. Okay, so looking at just the 3x, looking at the 6x, 3x times what is 6x? 3x times positive 2 is 6x, multiplying around the corner. Positive 2 times the whole 3x plus 2. That's 2 times 3x is 6x. 2 times 2 is positive 4. I'm subtracting the whole thing. 6x minus 6x, that goes away. Negative 3 minus positive 4 is negative 3 minus 4. I am left with the remainder of negative 7. Now, what do I do with that? Well, remember I said the way we're going to deal with negatives, or sorry, not negatives, remainders, is going to be most similar to the fraction method. So we have a minus 7. I'm going to go minus 7 over what we're dividing by, 3x plus 2. So that's the answer. 2x squared minus 3x plus 2 minus 7 over 3x plus 2. The remainder of negative 7 becomes minus 7 over whatever we were dividing by. Let's do another. Let's take a look at negative 5 plus x plus 4x squared plus 2x cubed plus 3x to the 4th. Plus 2x cubed there, plus 3x to the 4th, divided by x squared plus 2. When we write this as long division, divided by x squared plus 2, we're going to remember to keep our placeholder. So divided by x squared plus 0x plus 2. Underneath, we also want to rearrange now, because just like we needed to keep the placeholders, we need to keep the pattern. So it would be positive 3x to the 4th plus 2x cubed plus 4x squared plus x minus 5. All of these terms are plus except for the minus 5. So now we can do our work. I have a feeling there's going to be some form of a rewrite in my future, but we'll avoid that for as long as possible. Just look at the first term, the x squared, the 3x to the fourth. X squared times what is 3x to the fourth? X squared times 3x squared is 3x to the fourth. Multiply around the corner. Multiply by the entire x squared plus 0x plus 2. 3x squared times x squared is 3x to the fourth. 3x squared times 0x, that's going to be a 0x cubed. 3x squared times positive 2, that's positive 6x squared. Subtract, but make sure you have your parentheses because you're subtracting the whole thing. Three x to the fourth minus itself. Bye-bye. 2x cubed minus 0x cubed. That's just positive 2x cubed. Positive 4x squared minus positive 6x squared is 4 minus 6 of them. That's negative 2 of the x squareds. Bring down the plus x minus 5. We go again. X squared times what is 2x cubed? Well, x squared times positive 2x is 2x cubed. Multiply that positive 2x around the corner. That's times this entire thing. 2x times x squared is positive 2x cubed. 2x times 0x, that's a plus 0x squared. 2 times 0 is 0. 2x times positive 2, that's positive 4x. We're going to subtract that whole thing. 2x cubed minus itself. Bye-bye. Negative 2x squared minus nothing. That's still minus 2x squared. X minus 4x. 1 minus 4 would be negative 3x. Bring down the minus 5. X squared times what is negative 2x squared? X squared times negative 2 is negative 2x squared. Multiply it around the corner. Negative 2 times this whole thing. Negative 2x squared minus 0x. Negative 2 times positive 2 would be negative 4. Subtract the whole thing. This is where I find some room by just giving a little push. Negative 2x squared minus itself. Bye-bye. The bye-bye step. That's how we're making sure we're doing the right thing. Negative 3x minus nothing. It's negative 3x. Negative 5 minus negative 4. That's negative 5 plus 4. Negative 1. Nothing else to bring down, which means this is the remainder. Since this is a whole term, I'm still going to go ahead and I'm going to write this as plus. I'm not going to take the minus because it's not just a single term. If this was just minus 3x, I'd put minus 3x over whatever. If it was just the minus 1, I'd put minus 1 over whatever. But since it's this whole thing, I'm just going to add on the remainder. I'm going to add on negative 3x minus 1 over what we're dividing by, and we can put it back to its shortened form. We divided by the x squared plus 2. That is correct. Let you take a moment and finish with that. Now, objective 3 in this topic is using synthetic division to divide a polynomial by a binomial. Two x squared plus 3x minus 14 all over x minus 2. Since we're dividing by x minus 2, we can't do the split up method. We have to do long division. Hey, that's a good one. So underneath 2x squared plus 3x minus 14 on the outside divided by x minus 2. X times what is 2x squared? X times 2x is 2x squared. Multiplying around the corner, 2x times the quantity x minus 2. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Subtract the entire thing. 2x squared minus itself. Bye-bye. 3x minus negative 4x would be 3x plus 4x, or 7x minus 14. X times 7x, or sorry, x times what is 7x? X times positive 7 is 7x. Multiply around the corner. Positive 7 times the entire x minus 2. 7 times x is 7x. 7 times negative 2 is negative 14. Subtract the whole thing, and we see 7x minus 14 times its entire self. That's a double bye-bye step. We have no remainder. So 2x plus 7. Just like any division problem, we can check with multiplication. Let's just double check 2x plus 7 times what? 2x plus 7, let's check it times x minus 2. Let's make sure we get 2x squared plus 3x minus 14. And if we FOIL, 2x times x is 2x squared. 2x times negative 2 is negative 4x. Plus 7x minus 14. Combine like terms. 2x squared plus 3x minus 14. It checks. We got it. And how would we check if we had a remainder? Well, just like we would add the remainder on, we do this part times that part, get an answer, add the remainder on, and it should give us what we started with. That's the whole point of a remainder. The multiplication gets us as close as possible, but then we have the remainder left over to take us the rest of the way. If we had a remainder, we would add it onto this, and that would give us what we needed. And that's how we would check. So that is long division. You know, it occurs to me, what is it they say in commercials when they're trying to sell you a product. There has to be an easier way. And sometimes there is. We have something called synthetic division. Synthetic implies not actual. If you had a synthetic material, that would mean a not natural material, something that was created. Synthetic division is a way to get around long divisions on problems like this, where it's just x plus a number or x minus a number that we're dividing by. Here, x minus 2. So the first thing when we have synthetic division is going to be x minus what? That is the first question we ask ourselves. X minus 2 here means that our what is going to be 2, positive 2, because x minus 2 is what we're dividing by. So I want to write this problem again. We have 2x squared plus 3x minus 14. We are dividing by x minus 2 and we get 2x plus 7. Okay. So we're dividing by x minus what? We're dividing by x minus 2. The first step that we're going to do is we're going to create a little box and we're going to put that 2 into the box. Promise you this is going to be really confusing at first, but then once you get it, you're going to love it. We're going to use it so much. I'm not kidding. We're going to put the coefficients, the thing we're starting with. We have a 2x squared, a positive 3x, and then a negative 4. So the coefficients of the top go in the rest of this row. So our 2 is protected in this little box. 2, 3, negative 4, those are the coefficients. Here is what we do. We're going to bring our first number down under this bar. And then we're going to proceed to multiply and add, 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 multiply and add. Okay. So this is our new brainwashed thing. When I hear multiply in terms of synthetic division, I want my brain to go and add, multiply and add. We're going to start out here. 2 times 2 is 4. 3 plus 4 is 7. Multiply. 2 times 7 is 14. Add. Negative 4 plus 14 is 10. So I brought the first number down and then I multiplied and added. I multiplied and added. I didn't get the right number because, of course, this wasn't minus 4. It was minus 14. I'm so sorry. I'm so sorry. I was doing so well. I really was. It was minus 14. So 2, 3, and negative 14 were my numbers. I'm so sorry. Bring down the 2, multiply, and add. Multiply, and when I add, I get 0. Here's what we do with that. What did we start with? It was a 2x squared. Let's lower that by 1. So it's just an x. 2x, positive 7, no remainder. Now, I know I screwed that one up, so that wasn't as impressive. I guess we're going to have to keep doing some examples to become impressive. Let me see if I can find another one that we did earlier. The one that would work is the one I made up, and I don't have that offhand. So I guess instead of staying at the same level, and comparing it to an answer we already know, I'm just going to start with a fresh problem. Minus 28x minus 7, 4x cubed minus 28x minus 7. We're going to divide by x minus 3. So what goes in the box? X minus what? X minus positive 3. What are our coefficients? We have an x cubed, positive 4. What's our x squared? We don't have one, placeholder. What's our x coefficient? Negative 28. Now what's our constant? Negative 7. Bring down the first number, multiply and add, multiply and add, multiply and add. I'm hearing the Borat come out again. Bring down the first number, bring down the 4. Multiply, 3 times 4 is 12. Add, 0 plus 12 is 12. Multiply, 3 times 12 is 36. Add, negative 28 plus 36, that's positive 8. Multiply, 3 times 8 is positive 24. Add, negative 7 plus 24, it's going to be positive 17. We started with an x cubed, so we drop it to an x squared plus a 12x plus just an 8, and then plus our remainder is going to be 17 over x minus 3. Four x squared plus 12x plus 8 plus 17 over x minus 3. We got our answer without having to do long division, because we could use the shortcut of synthetic division because we just had a regular x and then with something. It could be x plus, it could be x minus, but if it's just an x and then plus or minus something, we figure out it is x minus what. Put that in the box, get our coefficients in order with placeholders if we need them, put down our bar, bring down the first number, multiply and add until we get to the end. Then since the last thing has to be our remainder, we're going to lower everything by 1. We started with an x cubed, so we start filling in with x squareds. Positive numbers that we get become pluses. Negative numbers that we would get become minuses. Let's do some more. You're going to need some practice before you're comfortable with these. Negative 2x plus 4x cubed plus 18 plus x to the fourth divided by x plus 2. Now I'm going to rewrite this. I'm going to rewrite this in decreasing power of x. It's divided by x plus 2. We start with an x to the fourth. Where's our x cubed? Plus 4x cubed. Where's our x squared? We don't have one, so plus 0x squared. Where's our x? Minus 2x. Where's our constant? Plus 18. So in decreasing power of x with our placeholder, we have x to the fourth plus 4x cubed plus 0x squared minus 2x plus 18, all divided by x plus 2. We're dividing by just an x plus something or an x minus something. So we can go ahead and use synthetic division. The question is divided by x minus what? It would be x minus negative 2 to give us our x plus 2. Negative 2 goes in the box. Our coefficients, 1, 4, 0, negative 2, positive 18. These start with an x to the fourth, so when we're all done, we're going to start x cubed. Fill in from there. Bring down our first number, 1. And then what do? Multiply and add, multiply and add, multiply and add. King of the castle. Negative 2 times 1 is negative 2. Add 4 plus negative 2 or 4 minus 2. That's 2. Multiply negative 2 times positive 2 is negative 4. Add 0 plus negative 4. 0 minus 4 is negative 4. Multiply negative 2 times negative 4 is positive 8. Add negative 2 plus 8 is positive 6. Multiply negative 2 times positive 6 is negative 12. Add 18 plus negative 12, or 18 minus 12. It's positive 6. That's going to be our remainder piece. We had x to the fourth, so we lower it to 1 single x cubed. Positive 2, so plus 2x squared. Minus 4, so minus 4x. Positive 6. Plus 6. And then our remainder would be a plus 6. Over, we divided by x plus 2. So we get this answer from our resulting line of 1, 1, 2, negative 4, positive 6, positive 6. Since it started as an x to the fourth, we would fill in with x cubed, x squared, x, no x, remainder. Let's go again. Let's take a look at negative 3x plus 7x cubed plus 5 plus 2x to the fourth. And we're going to divide by x plus 1. We're dividing by x minus what? X minus negative 1 is how we get x plus 1. Our coefficients, highest power we have is an x to the fourth. That's a positive 2x to the fourth. A positive 7x cubed. No x squared. Negative 3x plus 5. Bring down the first number. Multiply and add. Multiply and add. Multiply and add. Multiply and add. From this bottom line, our final answer, since we started with x to the fourths, this would be x cubes, positive 2x cubed, plus 5x squared, minus 5x, plus 2, and then a remainder of positive 3 means plus 3 over, what were we dividing by? X plus 1. Objective 4 in this topic is using the remainder theorem to evaluate polynomials. The remainder theorem states if a polynomial p of x is divided by x minus c, then the remainder is p of c. What? Use the remainder theorem and synthetic division to find p of 4 if, that should say if, not is, p of x is 4x to the 6th minus 25x to the 5th plus 35x to the 4th plus 17x squared. So we know p of 4 means x equals 4. We could do 4 to the 6th and get a big number, multiply that by 4, get a big number. Do 4 to the 5th, get a big number, multiply that by negative 25, get a big number. Do 4 to the 4th, get a big number, multiply by 35, get a bigger number. And then square 4 gets 16, multiply 16 by 17, add that on to the end. We could do that, but those numbers are big. Instead, the remainder theorem tells us just do synthetic division with 4, and the remainder is p of 4. That's crazy. So synthetic division with 4. What are our coefficients? Highest power is 6. So 4, positive 4. And then the x to the 5th has a negative 25. And then an x to the 4th has a positive 35. And then it's x squared. We had no x cubes. We need to account for that. So 0x cubed. And then positive 17x squared. And then we need to account for the rest. Plus 0x plus 0. Bring down the 4. Multiply to get 16. add to get -9. Multiply to get -36, add to get -1. Multiply to get -4, add to get -4. Multiply to get -16, add to get 1. Multiply to get +4, add to get 4. Multiply to get +16, add to get +16. So this last number we get, the remainder, is P of 4. That's remarkable. We didn't have to deal with all those huge numbers, 4 to the 6th, 4 to the 5th, 4 to the 4th, multiply by 4, 25, 35. We were able to do synthetic division on 4, get the remainder, and have that be the answer. Thus, P of 4 is 16, the remainder. And that is it for this topic. The topic is solving equations containing rational expressions. Objective 1 in this topic is solving equations containing rational expressions. To solve equations containing rational expressions, we're going to clear the fractions by multiplying both sides of the equation by the LCD of all fractions, then solve as usual. This is very similar to how we handle equations containing fractions. Step 1 was that optional clearing of fractions, or you can work with the fractions. We have the same options here. We can keep all the fractions and work with them, or we can get rid of them. Multiply both sides of the equation by the LCD and get rid of the fractions. So here, our common denominator that we're looking for is going to be 6x. How do we get that? Well, 6 is 3 times 2, so our unique factors are 3x and 2, all to the first power. 3 times x times 2 is 6x. So multiply both sides of the equation by 6x. We're distributing that 6x on the left. 6x times 5 is 30x. 30x divided by 3x is 10. 6x times 1 is plus 6x, so 10 plus 6x. On the right, the 6's cancel, leaving us with 7 times x, or 7x. Solve as usual. Subtract 6x from both sides, we get 10 equals x. Now, we check by replacing 10 into x in the original equation, making sure that what we get works. So 5 over 3 times 10 instead of 3 times x. That's 5 over 30 plus 1 equals 7/6. We need a common denominator. Actually, we can go ahead and reduce. That makes this a lot easier. 5 over 30 is 1/6. 1/6 plus 1 is 1/6 plus 6 over 6. That's 7 over 6, so we have a true statement. It does work. X does equal 10. One of the things we want to watch out for this one, for instance, we couldn't have x equals 0 because that would give us 0 in the denominator of one of the fractions. So if we would have solved and gotten x equals 0, we would have had to throw that out. So again, multiply both sides of the equation by the LCD of all rational expressions in the equation, simplify both sides, then determine what kind of equation you have, solve accordingly. We just saw a simple linear equation, but maybe we're left with a quadratic that we need to factor and solve. And then check the solution in the original equation, especially looking for dividing by 0. So let's solve the following rational equation. 1 over 2x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. We'll especially be watching out for values of x such as 0 or -1, things that make the denominators equal to 0. We factor. The 3x squared plus 3x factors to 3x times x plus 1. Our unique factors are 2, x, x plus 1, and 3. We already have the x. We already have the x plus 1. 2 times x plus 1 times 3 is 6x times x plus 1. That's the LCD that we're going to multiply both sides of the equation by. 6x times x plus 1 times 1 divided by 2x. The x's will cancel. 6 over 2 is 3, so we're left with 3 times x plus 1, and then minus, and then 6x times x plus 1 times 1 divided by x plus 1. We're just distributing. We're taking what's on the outside here and multiplying it by the second term. The x plus 1's cancel, leaving us with 6x. On the right, multiply the 1 by the 6x times the x plus 1. The x's cancel, the x plus 1's cancel, and 6 over 3 gives us 2. Distribute 3x plus 3 minus 6x equals 2. Combine like terms. 3x minus 6x is negative 3x, so 3 minus 3x equals 2. Subtract 3 from both sides, negative 3x equals negative 1. Divide both sides by negative 3. Negative divided by negative is positive, 1/3. We want to check that 1/3 works. So plug it back into the original equation. Not just on one side, though. On the other side as well. 2 times 1/3 is 2/3. 1/3 plus 1 is 4/3. 3 times 1/3 squared would be 3 times 1/9 or 1/3. 3 times 1/3 is 1. 1 over 2/3 is 3/2. 1 over is the reciprocal function, so 3/2. And 1 over 4/3 is 3/4. So we end up with 3/2 minus 3/4 equals 1 over 1/3 plus 1. 1/3 plus 1 is 1/3 plus 3/3. That's 1 over 4/3. 1 over 4/3 is the reciprocal of 4/3, 3/4. Get a common denominator, so 3/2 is equivalent to 6/4. We have 6/4 minus 3/4 is 3/4. That is a true statement. So our value of 1/3 does check. Now there was a lot going on fraction-wise in that check. So be careful when you're doing your checking work, because if you get a false statement, where did you really screw up? Did you screw up in the equation or did you screw up in the check? I don't know. It's just as likely. Let's solve 1 over x minus 1 equals 2 over x plus 1. And although we're going to use the LCD method to solve this, I'm going to point out that there is a method 2 that we could use. And I'm going to show you how we could apply method 2 to this problem as well. We'll talk more about method 2 in the next topic as well. We have 1 over x minus 1 equals 2 over x plus 1. The individual unique factors of the denominators are x minus 1 and x plus 1, which makes the LCD that we multiply everything by. X minus 1 times x plus 1. On the left, the x minus 1's cancel, just leaving us with x plus 1. On the right, the x plus 1's cancel, leaving us with 2 times x minus 1. Distribute the 2. Subtract x from both sides, add 2 to both sides, we get x equals 3. Before we move on to the check, I want to backtrack to this step. Does x plus 1 equals 2 times x minus 1? We can get there completely ignoring that middle step. Method 2 is get it in the form fraction equals fraction. Because remember, if we have fraction equals fraction, that's a proportion. We can solve that by cross multiplication. 1 times x plus 1 is 1 times x plus 1, x plus 1, equals 2 times x minus 1. Cross multiply. What we get when we do top left times bottom right, set equal to what we get when we do bottom left times top right. Cross multiplying directly sets up x plus 1 equals 2 times x minus 1. And everything is the same from there. So method 2, fraction equals fraction. That would require us to do all of our work with fractions, though. Get common denominators on both sides, add and subtract to simplify both sides down to fraction equals fraction, then cross multiply. But if the LCD method is working for you, let's just keep doing the LCD method. Works out the same way. Now let's check our x equals 3 in the original equation. 3 minus 1 is 2. 3 plus 1 is 4. 1/2 equals 2/4. That's a true statement. They're both 1/2. The solution is x equals 3. Solve the following rational equation. 12 over 9 minus a squared plus 3 over 3 plus a equals 2 over 3 minus a. Now, we know if we factor 9 minus a squared, that's a difference of squares. That's 3 plus a times 3 minus a. So our individual factors that are unique are 3 plus a and 3 minus a. That is going to be the LCD that we multiply both sides by. 3 plus a times 3 minus a. Multiplying the left side through. This times this. The denominator of 9 minus a squared will cancel with both of those, leaving just 12. Then the 3 minus a times 3 plus a times the 3 divided by the 3 plus a. The 3 plus a's cancel, leaving us with 3 times 3 minus a. On the right, the 3 minus a's cancel, leaving us with 2 times 3 plus a. Distribute to get rid of the parentheses. 12 plus 9 minus 3a equals 6 plus 2a. Combine like terms on the left. 12 plus 9 is 21. Add 3a to both sides. Subtract 6 from both sides. 15 equals 5a. Divide both sides by 5. 3 equals a. Check by plugging 3 in. Maybe you're already prepared for this from examining the original. But when we plug 3 in, we get some division by 0. And since we're not allowed to divide by 0, that means 3 is not in the domain of these rational expressions. Therefore, 3 is not a solution, which means that the answer is that there is no solution. So you may have been thinking, what was the point in checking all these? They all worked. They don't all work. Because we can't divide by 0, and sometimes we get a solution that causes us to divide by 0, in which case it's not a solution. So it is important to check the solutions